All right. You should be able to
Oh,
hear me
yeah.
now.
Yes,
There we
yeah,
go.
no.
Uh, well, Ian, thank you so much for that talk. I'm so sympathetic to that work. I hope you're going to be sympathetic with this as well. Um, so I'm going to be presenting on progressive web apps and client-side processing tools for ontology development workflows. Um, now, just an overview. First, I want to kind of look at agile knowledge engineering tools, and the state is that they're pretty sparse currently. We also have um, obstacles for getting some of these tools close to the data in the user's environment. And then I'm going to specifically focus on two examples of some tools that we've been implementing for agile knowledge engineering DevOps. This paradigm that we're getting into, which includes the tabular ontology maker, basically spreadsheet ontology maker, and then axolotl, a Sparkle endpoint that's in browser, and then the way forward, kind of modular development of an ecosystem. So thinking through how ontologies are often made, some ontologists have idealized their iterative development cycle into something like an agile development workflow. They start with user stories, identify what to draft, build, test, integrate, validate, and deploy. And that means typically we would start with competency questions, just kind of scope the domain, scope the, the data that we need to look at and identify those capability gaps. But there's actually a dearth of tooling for some of these steps. Ideally, we'd have some knowledge of, some software that collects the knowledge of different users through user stories and competency questions and allows us to take that same data that we've collected,
Vocabulary.
transform it, decompose it, query over it, and pass it around in the pipeline through reusing at different steps. And so we want to be able to reuse that when we look at the semantic model. And when we can answer that question, we want to have been able to trace it back to those initial list of terms and align the entities along the way to ontologies and expand representation. And so there may be specific tools for each of these junctures, but there's a lot of gaps. Now, I'm of the mind that each of these steps can have a modular software solution that can be used in the environment where the data is used or stored. So users, subject matter experts, things like that, people like that. The software should then be able to handle a wide variety of normalized outputs if it's modular, and then give highly normalized outputs. And we want that module to be set up for each step in the pipeline. So where someone can manually put some stuff in, we might have a modular one that can automate it. But wherever you are in the pipeline, you should be able to enter into the pipeline something normal and then pass it along around away you go. And then you keep going through the cycle. Now, there is a problem, however, with users handling sensitive data, whether PII, EFI, or otherwise restricted by policy in your organization, because the stakes are higher there, right? Someone has to accept the cybersecurity risks, whether it's the data is handled in a highly vetted cloud environment or managed by local IT, approving local installations. And since we want these tools to be in the hands of users and for applied ontologies, we want the data and the ontologies to have some resemblance. And so development is ideally supported by tools that are in that same environment. So we need to be able to get development tools closer to that sensitive environment. So how can we dodge it? Well, so here are some constraints that I'm operating under. What I'm trying to do is I'm developing modules that are accessible to non-experts in a sensitive environment. So there should be little or no server overhead, maintenance, database management, low or no installs on client computers, avoid the command line or Java virtual machines, because many policies, people just don't have access to those. And also still be able to process sensitive data without it leaving the user's protected environment behind the firewall. So some other things that I'm aiming for are that it's designed with knowledge engineering in view. So it's built for reading and writing in RDF, which is unlike Excel or PowerPoint. You can create transformers, but we're building in RDF, we're writing and reading in RDF. Also, doesn't have to be streamed to be useful in RDF, like creating a spreadsheet and then finding all these different ways to kind of manipulate and so on and so forth. And then also that it's modular for reuse in integration in a larger ecosystem. So if you have in view the OntoZoo or other environments, like you would want to be able to reuse as much as possible, and it doesn't have to be doing everything. It could be small and modular, but it also shouldn't be redundant with existing tooling. So I want to give you guys a view of the tabular ontology maker, which is a lot like Robot's ability to transform a spreadsheet, a normalized spreadsheet, into an ontology from the command line. This is all in the web browser. Now, can you see my web browser? I've switched tabs. Can you guys see the screen?
Yes.
Yes. Okay. All right. So the tabular ontology maker allows you to operate entirely in the web browser as a spreadsheet. So you can copy, paste, you can, add rows, you can hide rows, things like that. And you can take whatever normalized fields you have and preview an RDF, and it will give you a turtle file right away. You can export and so on. If you want to manage the ontology settings, you can say, hey, I want to name the ontology. I want to give the name. I can say things like I want opaque or human readable. A lot of things that you can see are available in Protege. Should be able to do that here too. You can fill in the IRIs and all that jazz according to your schema. If I want, I could insert data. If you don't have the normalized spreadsheet, you can just grab it from here. It'll download the template that you would need, or maybe you've already got it and you can just drag and drop in. If you didn't want to do either of those, you could just go to your spreadsheet and copy and paste. So I've got, the IRI label, element type, definition, and so on. I can just paste it right in. Boom. And if it's missing a row, it'll give it to me. I can again go preview, and all the stuff I added is already there. Now, it has a lot of limitations. You can currently manage some predicates. You can insert data, but not ontologies. And currently in the stable version, if you refresh the page, it'll start with this default. But in the next version, it will have full progressive web app support, so you can save across sessions. Now, so that's the tabular ontology maker. Now, just real quick to recap what I've been able to show. Everything that you've seen here is in a static web page. It's entirely client-side processing. The user's data stays local. You can load sensitive. Nobody can save your data if they never receive it. Nobody can get the data if it's never leaked. So there's also no installations, no zips, no command line. It just allows you to draft lexicons quickly and get native RDF. I could say more about, what ontologies it brings in, but I'd like to move to the next tool real quick. Axolotl is a Sparkle query and inference tool. It allows you to load your ontologies right into the browser. So I can say, hey, I want BFO and I want OBO metadata, and I can stash to active workspace. It'll load the ontologies right away into the web browser. And I can go query on it. Let's get all the triples. And I'll run the inquiry, and I'll get the 1,500 or so triples right away. You can see that that's performed very fast. I can name graphs and so on in the thing natively. And here is actually the reason why I made this. I wanted also to be able to run inferences using forward chain reasoning on some graph data. I can run an inference and it'll give me materialized triples of all the implicit data as long as I have the axioms in the same space. And I can now save that as an overlay. So it doesn't infect the ground truth base knowledge that we want. Or I could save it as a named graph and stash it into active workspace. And it will save that, and it will not be in the other graph that we've been basing this on. Now, all of this, I could also point to an external query endpoint. I could set up a Sparkle endpoint here and point instead to a different Sparkle endpoint and run those queries there. So what have I been able to show? I can also do this in a static web page hosted by, say, GitHub or GitLab. It's entirely client-side processing. User data stays local unless you want to point to an external endpoint. And there's no installations, no zips, no command line, no database management. It supports Sparkle queries, and it allows you to materialize triples. It's all in the browser. So where this is going is we've got tools, modules for many of the different steps, and we're expanding out. So features to be developed include full progressive web app support. I already mentioned this, being able to save across sessions, have offline mode, things like that, as well as a curation status management. Hey, in a spreadsheet, I want to tag make sure everything's metadata complete before I, commit it to the pipeline or whatever. And then for axolotl, being able to serialize in different formats and handle authentication. Thank you for your attention and your time. I also want to specifically thank Aaron Damiano, co-laborer in expanding this agile ontology development ecosystem. He's been making different tools that fit with the tools that I'm making. And if you want to play around, you can go to those public web pages. And I have the dev beta versions for some of these if you want to test some more experimental features. Thank you so much.
Yes, thank you for your talk, Jonathan. Yeah, there's one question in the chat. Can you compare Tom with Web Protege for community use?
Yeah, so there's a lot of capabilities that Protege has that are amazing. Protege's got so many different tools in its set. Web Protege, I believe you need to create an account, or even if you don't need to create an account, I think you're still using their servers for handling some of the processing. I could be wrong on some of those details, but those capabilities right there are a showstopper for a lot of environments that I'm specifically speaking to. In our organization where I work, which I haven't named yet, we have highly sensitive data, and we cannot have it traverse the boundary. We can't upload things to be processed and things like that, have accounts managed for some of these things. So that's a good showstopper. The second thing is Protege, whether you're using the web browser or the one that runs from Java, has some of these capabilities working pretty well, where you can see in a tabular way all the different predicates, and you can say which predicates you want to look at and which ones you don't. I have not found it very easy to copy and paste in groups all the different things that I want to be able to look at, which is really just a flattened ontology into a table. Robot does a lot of what I'm doing better and faster probably, but this is in a web browser. So I think that for this tool and the others, there's some trade-offs. But I would compare, and I've heard this comparison for my tabular ontology maker, that it's like Paint for ontology development, which I would take to be a compliment because I love Paint. It's not Adobe Premiere, it's not GIMP, but it has many of the things that I need to do drafting quickly.
Yeah, thank you. I have also a small question. So could these tools enable collaborative editing? For instance, have you considered browser-based peer-to-peer synchronization or shared modeling sessions?
Yes. So Aaron Damiano and I have been researching and gotten to prove in some use cases using API tokens to make commits to a pipeline. I'm sorry, to a repository. And in those repositories, since your API tokens give you all of the authentication and cybersecurity and authorization that you need, we don't need to handle sign-ins or user accounts or things like that. It's just handled at the repo level. So if you have an API token, you can commit, and then as long as people have the service workers making sure that the base information is up to date, synced with the pipeline that's made public, then you're good to go. But we're still experimenting on exactly how that's going to work. We have in view doing that for all of our program management. So if you have a wide variety of projects that you're developing, you could actually have different projects all saved in a repository. That's the idea. That's where we're going. But yeah, we're definitely in view having the collaborative environment.